So student, we shall be dealing about the Lewis dot structure in this session. Friends, after completing type of bonds, that is ionic, covalent or coordinate, I hope we are well aware about the type of possible bonding between two atoms. Like if I ask the type of bond between sodium and oxygen atom, then I am able to fill the noise that sir, it must be ionic. I hope reason is well known to us that here we are finding that in bonding we have the involvement of a metal and a non-metal. Now, as already discussed, that between a metal and a non-metal we have the formation of ionic bond. So the answer for this question, that between sodium and oxygen atom, as we are finding that one is the metal, other is the non-metal, so the possible bonding will be ionic bonding. Similarly, if I ask that what type of bond is possible between nitrogen and hydrogen atom, then again without hesitation you will say covalent. Again, why? So let's see here. The question was the type of bond between nitrogen and hydrogen atom. Here nitrogen is a non-metal. Similarly, hydrogen is also a non-metal. So here we are finding that since both these atoms which are involved in the bonding are non-metallics, so the possible bond must be a covalent bond. Now coming to another example, if I ask, my dear student, what kind of bonding is observed between NH3 and H positive? So here we have two species, one is the NH3 and other is H positive, and we are supposed to find out the possible type of bonding between these two species. Again, I feel that your answer must be a coordinate bond because we have already dealt about this type of bonding. Here H positive is electron deficient, which requires a pair of electron to get stabilized, and in NH3 nitrogen has a presence of lone pair, that is it has two electrons in its valence shell which is unshared. We can see here that in nitrogen we have 5 electrons in the valence shell, whereas hydrogen has 1 electron in its shell. Now to complete the octet, nitrogen will share 1 electron from every hydrogen atom, and similarly hydrogen atom will share 1 electron of nitrogen atom. So we are finding here that after bonding between nitrogen and hydrogen in NH3, it has got 2 electrons which are still unbonded, unshared, and we call this pair of electron as lone pair, which is available with the nitrogen atom in NH3, which can be further shared to H positive such that it could get stabilized. Now we can draw the structure as NH3, where it has got a lone pair, and H positive to complete the octet will share this pair of electron. So here we are finding that basically there is no involvement of any electron from H positive ion, rather it is only sharing a pair of electron, that is lone pair of nitrogen atom belonging to NH3. So this bond will be called as a coordinate bond. This can be also drawn as NH3. Since NH3 is sharing its lone pair, that means it's the donor atom. So on donor atom we have the positive charge, and on the acceptor atom we have the negative charge, and as we are finding here that H has got already a positive charge, so positive negative will cancel each other, forming H only. So this how also we can represent this coordinate or the dative linkage bond. So in this 3 example, starting with the sodium and oxygen, where we found that the type of bond was ionic. In the second, we had nitrogen and hydrogen, where the possible bonding was covalent bonding. And in the third, we had ammonia, NH3 and H positive, where H positive was electron deficient, which was requiring 2 electrons, that is a pair of electron to get stabilized, which it is sharing from nitrogen belonging to NH3, forming a coordinate bond. So ionic bond, covalent bond and coordinate bonds are now totally well known to us. After having a complete concept of type of bonds, we'll move towards Lewis dot formula, or we can call it as Lewis dot structure. Let's first take an example of H2O. So for starting Lewis dot structure, we are moving towards an example taking H2O. This H2O molecule can be written as O, we had then H and H. Now in the valence shell of oxygen, we have 6 electrons, 1, 2, 3, 4, 5 and 6. And in the valence shell of hydrogen, we have 1 electron. Now for the completion of the octet, what we find that since oxygen has 6 electrons in its valence shell, so it will share 1 electron from each of hydrogen atom, completing its octet. Similarly, hydrogen, to attain noble gas configuration, that is configuration similar to that of helium, it will share 1 electron from oxygen atom, attaining stability. The same representation can be made as HOH, or we can represent this structure as follows: H OH. So these are the three different type of representation which we can make for H2O molecule. In the very first, we are trying to complete the octet, or we can say for hydrogen we cannot use octet word. So we are just trying that in this representation every atom should attain noble gas configuration such that their potential energy should decrease and they could attain stability. Now using this one, the first structure, we have drawn the second one where we are finding that oxygen is gaining, or it is having 8 electrons in its valency shell attaining noble gas configuration, and hydrogen is acquiring 2 electrons in its valency shell attaining configuration similar to that of helium and hence getting stabilized. Here, since we are finding here that between O and H atom, we have the involvement of 1 electron from both the atoms. So we can represent this involvement by a single covalent bond also. The very comparing these two, that is, let us call it as first and this one second. The first structure is representing the Lewis dot formula, while the second is representing dash formula. So I would like to make you people aware about a fact that whenever we only represent a molecule through electrons or dot, then in that case we have to call it as a Lewis dot formula. And whenever we use bonds to represent a molecule also showing the available lone pairs, then in that case we have to call it as a dash formula. Basically, Lewis dot formula is used to represent atoms covalently bonded in a molecule or a polyatomic ion. So now we are moving towards the Lewis dot formula. So student, Lewis dot formula is used to represent atoms covalently bonded in a molecular polyatomic ion. That means we can also use this formula in case of charged species like SO4 2 negative or NO3 negative. In that case also we can use the Lewis dot formula. Remember student that this formula, that is the Lewis dot formula, only represents the valency electrons, the number of and kind of bonds, but do not depict the 3D shape or geometry of a molecule. That means through this formula we cannot determine the shape of a molecule. Rather we can just represent the valency electrons of the atom in a molecule and the type of possible covalent bond in it. So let us take it as a note. So Lewis dot formula only represents the valency electrons, as we could see in case of H2O that we are only using the valency electrons of oxygen. It represents the kind of bonds and the number of bonds involved, as here in H2O we are finding that we have the involvement of covalent bond between O and H, that is the nature of bond, and only we have got one bond in each cases. So nature of bonding and number of bonds can be determined through the Lewis dot formula. But it's very important to notice that through the help of Lewis dot formula we can never determine, or it does not represent the three-dimensional shape or the geometry of a molecule. This formula is based on the fact that the representative elements achieve a noble gas configuration, with certain exception of atoms where they do not attain 8 electrons configuration, as we find in case of hydrogen, that it only attains helium gas configuration. So again we have got another note where we can see. So the basic fundamental of Lewis dot formula is that every element involved in the molecule should achieve noble gas configuration, but we also find certain exceptions where elements do not attain 8 electron configuration, like in case of H2. So we can observe in case of H2 that hydrogen has 1 electron in the valency shell, and to get stabilized the sharing occurs in this way, forming H single bond H. So here only atoms, that is hydrogen atom, is attaining 2 electron configuration, that is helium configuration. But in most of the cases what we find that during writing a Lewis dot formula we find that elements involved in the molecule gains noble gas configuration.